Hello, I'm Nathan Tranquilla, and in this video I'm going to be showing you 5 ways in which ReScript fixes TypeScript with a focus on their type systems. Now on this channel we're all about next generation web dev languages, so this video will be about how ReScript has the type system to be considered amongst other next gen web development languages. Number 1, unsafe array access. So in TypeScript you can still unsafely access elements in an array and end up getting undefined at runtime. Now, normally with strict mode enabled, that would be enough to prevent this. However, in the case of the dynamic index, where the index is a variable, you can still run into this problem. So let's take a look at our TypeScript code right here. We've got a function called unsafe dynamic access. It inputs an array and an index, and it outputs a number. So we're trying to get an element out of that array by index. Now here I've constructed an array of size of length 3, and I've created a loop where I've misunderstood my bounds. So I've got, I access it 5 times instead of 3 from 0, 1, 2, 3, 4. And as a result, I get 10, 20, 30, and then 2 undefineds. And so this is an example where TypeScript just does not, its type system isn't complete enough to prevent unsafe array access. Now, how would we do this in ReScript? So in ReScript, no matter what we do, when we access an element in an array, we return an option type so that we can handle whether something is present or not. It's as simple as that. Number 2, null safety. So in TypeScript, we still have the concept of null because JavaScript has the concept of null. Of course, what we know with TypeScript is that it's a static overlay over the language. And so there are certain compromises that need to be made to be backwards compatible with JavaScript. And one of those compromises is that the concept of null still persists. So here we have a TypeScript snippet in front of us. We are trying to access an element on the DOM, and to handle its presence or not presence, we define that with a type union. So we either have an HTML element or a null. And so null is expected and still present in TypeScript. So how do we do this in ReScript? So we have a similar snippet in ReScript, and here we're also accessing an element from the DOM. However, instead of having a type union, there's no concept of null in ReScript. It's been entirely removed, although you do still have to handle the reality of something being present or absent. And so how that's done in ReScript and other web dev languages like Rust, we have the option type, and the option type allows us to account for that scenario where the DOM was present on the in the document or it wasn't. Number 3, implicit conversion. Now, while TypeScript makes implicit conversion less of a problem in JavaScript, it's still possible to run into pitfalls with implicit conversion. Now, I've set up a scenario here where we're dealing with numbers, but we want, as is the case in JavaScript, sometimes numbers can come to us in string form. And perhaps instead of dealing with it at the root of where we first parse the number, we're pushing it back in the code to perhaps the comparison function. And the decision's been made, a poor decision, but the decision has been made nonetheless to account for these varied inputs right at the compare values function, where we input not only a number, but also a string. So it's a type union of string and number. And the tricky thing about this is that it works 50% of the time, right? So you might try 2 valid examples, comparing 10 the number and 2 the string, and you might see that it works, and you're like, great, implicit conversion is working. I don't need to worry too much about this. You try also 2 the string and 10 the number, and you get it correct, and you think, great, okay, maybe that's all the tests you're right, or maybe you're just verifying it manually. But of course, when you compare string to string, you run into the problem of lexicographical comparison, where 10 the string is compared to 2 the number, and then the intent of the comparison is all off, and it doesn't work. So you get the wrong answers in those cases. So the tricky thing about this is that you can kind of see how it would happen, and it's right 50% of the time. And so it's a problem. It's a problem. Implicit conversion is still a problem in TypeScript. In ReScript, there is no way to implicitly convert values. All values have to be explicitly converted. And so here's an example of where we have 1 the number and 2 the float. And we can't just add 1 plus 2. We have to first convert 1 to a float, or you could have just, in this case, written it as a float. But for the sake of example, we're converting 1 to a float, and then we're adding 2 floats together. And that's, if you're wondering, that's what that plus dot operator is. It's a operator for adding 2 floats. Number 4, duck typing. TypeScript has no nominal distinction between types. This means that if a type has the same structure as another type, then they are considered the same. So let's go through a snippet in TypeScript showing how this could go fatally wrong. So we have in this scenario a user profile type, a payment details type. They have the same properties, except payment details has to do, the balance really is meant to semantically represent debt, whereas the user profile balance represents funds. So we have a function to display it based on the user profile. And if we happen to input dynamically something that has the same shape as user profile, but is not a user profile, like payment details, then it can still be accepted as input to display funds. Now, obviously this is wrong. We're displaying debt instead of funds, and that can go fatally wrong. Now, in ReScript, there is no such implicit conversion. Types are distinct by name. They're nominally distinguished. And just because they happen to share the same properties does not mean that they can be treated as the same. There's no duck typing. So here I've got an example where A is being coerced to B, but that has to be not an implicit, but an explicit step. So if I try to put A into a function meant for B, then the program will not compile, the application won't build. You can only explicitly convert from type A to B. Number 5, exhaustiveness checking. In TypeScript, you can achieve exhaustiveness checking if you have the right strict settings enabled and if you happen to code the code correctly. So let's take a look at an example in TypeScript. So here I have a type shape, and it's a type union. Right now, the only shapes we have are a circle and a square. We have a function which handles both cases, but I've really only coded for one. In the default statement, we just assume what else is there. If not a circle, it's a square. Now this works, and it works right now, and it works, but it might not work in the future. Let's say we come along and we add another type to the shape. So we have a circle, a square, and a rectangle. Now there's nothing in my application code right now to warn me that I haven't coded for all the cases. It will compile and it will work and give me the wrong answer at runtime. Now, how would we handle such a thing in ReScript? Now over in ReScript, we have true exhaustiveness checking. So here we have a type shape, it's a circle, it's a square, and if we ever add another case to the shape, then the application will fail to compile, and it will warn us that we aren't handling all the cases in our switch statement. So it's prohibited. We have true, and there's no way to get around it by writing the code in some sneaky way. You have to match on all cases. So that's true exhaustiveness checking in ReScript. ReScript is so much like JavaScript, and I'm convinced even that as developers start integrating them into their code base, they're going to find that other JavaScript developers will have no problem maintaining them. I hope you've had a chance to see in some of the code that we've written in ReScript in our examples that it is so much like JavaScript, and it's just a little bit better. The type system is why I consider ReScript to be among other next-gen web development languages. But stick around because there's other reasons why ReScript is next-gen. Until then, bye now.